So, reminder, if you check your gold sheet on the front and the back, chapter 1 is on the front, chapter 2 is on the back. So we're starting chapter 2. You can see on the sideboard over here, we've got notes mainly this week. Next week, I think we do an extra set of notes for 2-4 on Monday, and then we have like a day of review and a quiz or something like that next week. Then we have a couple of days of review and then a test the following week. Next week is another 4-day week. So just kind of be aware of that and what's coming up. If you're ever absent or you're going to be absent, look at your gold sheet. It tells you exactly what you're going to miss. If you see like a worksheet or something that you can get from me before you go, great, ask for it. If you notice that you missed a quiz or something like that, feel free also to email me and make arrangements for your makeup. So we're moving on to 2.1, and we're going to talk about transformations of quadratic functions. Essentially, this section is the same thing that we were doing in the previous chapter, in chapter 1, but we're doing it with a parabola instead of the b. So we're going to see some very similar statements, maybe add in a few new ideas. And then tomorrow and also on Thursday, we'll be looking at some different forms for a quadratic. So they're not in the transformational form. But we're going to define or talk about a few things just so everybody's clear. And these things you should know from Algebra 1. So what makes something a quadratic function? How do you know it's quadratic?
That's 4 of something. Probably.
But you've seen quadratics before. What did they look like?
Isn't it like x squared?
It has an x squared. Now, it's important to note that x squared would be the highest term. If it's x cubed, x to the 4th, x to the 5th, that's something we call a polynomial. And we're going to cover those in a later chapter. But right now we're focused on highest exponent is 2, it's an x squared. That makes it quadratic. If it doesn't have the x squared, if it only has the regular x, then it's linear. And we know if it has absolute values, then it's an absolute value function. Parabola is the shape of any quadratic function. And you might describe it as a U shape. So we're going to talk about moving the parabola on the coordinate plane. Really important here. If on the chapter 1 and 2 test, which happens in a couple weeks, it's a quadratic function, and you're asked to graph it, it should look like a U. I have a hard time giving partial credit on a graph if you draw a V when it should be a U. Right, it's not linear or it's not absolute value. So really pay attention to those parent graphs and their functions. The vertex of the parabola, I'm going to describe. Some people say it's like the turning point. Okay, so where it would turn from decreasing to increasing or vice versa. It turns around or changes direction. And then you might also say it's like your min or your max. And we also talked about a vertex with the absolute value, right? The vertex was like the corner of the V. So that's also a really important point on these graphs. Any clarification or questions or other descriptions people have about quadratic functions, parabolas, or vertex? Okay, so today we're going to talk about one form of a parabola. It's called the vertex form. Sometimes you might hear people refer to the vertex form as the transformational form. It's called that transformational form because you can see the transformations, like right, left, up, down, flex, stretch, shrink, all those things that we did previously. tomorrow and on Thursday, we'll look at some different forms of a quadratic where the transformations are not apparent in the equation. We have to do a little bit more digging to figure out what's happening. Okay. So vertex form is the one that looks like f of x, or you could say y equals a times x minus h squared plus k. That would be my vertex form. And we know from chapter 1, and you can look back in your check or in your notebook about what do those things do, right? A is responsible for stretching or shrinking, also for reflections in the x-axis. H moves our graph left or right. It looks like the opposite of what we think it will do. K moves our graph up or down. Okay, so those things remain the same. And in the vertex form, we also talked about this in chapter 1. It's called vertex form because I always tell my students, it's the vertex is staring at you in the face. What's the vertex of that parabola? HK. Excellent. So let's write that as an ordered pair. HK. And some people may make a side note. H looks like the opposite. So if it's x minus 3, the H is really a positive 3. If it's x plus 4, the H is really a negative 4. H looks like the opposite, but K looks like what it is. So it's only the H. And the reason why that is if you go back to this vertex form, see at the very beginning you're putting a negative in front of it. So if I drop in a positive 2, then it looks like x minus 2. Now there's another thing that we're going to be looking at. It's called the axis of symmetry. Have you ever heard of the axis of symmetry before? Hannah is saying yes. Okay, I abbreviated it AOS. The axis of symmetry is the line. Okay, so an axis is really just a line. The line of symmetry for the parabola, that line is a vertical line that passes through your vertex, right? Okay, so that the parabola reflects onto itself. I'll maybe draw a picture right here of a parabola. There's my axis of symmetry, so this arm reflects onto that arm. Okay. And the axis of symmetry, it has to go through your vertex, and it has to be a vertical line, so we will write it as x equals h. So if my vertex is at 2, 3, then my axis of symmetry is at x equals 2. Done. If you already have your vertex, axis of symmetry is very easy.
Would it be possible to have a parabola that's like sideways?
Okay, so there are parabolas that are sideways. They exist. However, we are not studying them right now because we are focused on functions, quadratic functions. And in order to be a function, you have to pass the vertical line test. Well, a parabola on its side is not going to pass the vertical line test. You'll get to sideways parabolas in pre-calculus when you cover conic sections.
And would the axis of symmetry still be
Then the axis of symmetry would be y equals.
Okay.
Yeah. Okay. Excellent. Moving on. Okay, we're going to look at a few examples. I'll turn down the lights so we can see these a little bit better on the screen. Basically, if you want to jot something down in terms of directions, you're being asked to describe the transformations, which we've already done, and I would maybe practice like labeling vertex and axis of symmetry. This particular section doesn't ask you to do that, but tomorrow does. Label the vertex, label the axis of symmetry. So I think get a head start on it. You have both done. Okay, so talk to your table mates real quick. G of x equals x minus 3 quantity squared. Tell them what transformations are happening to that graph.
It's going right.
X minus 3 quantity squared. Abby, what's happening to that graph? to the right 3. Talk to your groups, okay? So I can call on anyone. We'll have an answer. All right, let's write that down. Right 3. Graph it. 1, 2, 3. That's going to be my new vertex. So if I wanted to label the vertex, I could say the vertex is at 3, 0. It's an ordered pair. And then just like we did previously for the absolute value function, use what you know from the parent function. Okay, so normally with the quadratic, you have your vertex, and then your next 2 points are up 1, right 1, up 1, left 1. Okay, so we can plot those points. We're going to go up 1, right 1, up 1, left 1. If you wanted to get some other points, what's the next move? Luke? You could make a table of values. What about from your parent graph? Instead of going like up 1, right 1, up 1, left 1, on the parent graph, what's the next number? So we're getting those from 1 squared is 1, and negative 1 squared is 1. So if you wanted some additional points, the next ones would be 2 squared, which is 4, and negative 2 squared, which is also 4. So then you could go up 4, right 2, up 4, left 2. Now, I don't need you to do that many, but just as a side note for later, if you wanted some additional points, you could also use what you know about the parent graph. So I'm going up 4, left and right 2. Draw the graph. And then I'm also going to do an axis of symmetry here. Okay, picture the vertical line passing through the vertex of your parabola that makes the parabola map onto itself. That axis of symmetry is happening at x equals 3. Okay. All right, have your group try this one together. G of x equals quantity x minus 2 squared minus 2. So do the same things we did. State the transformations, graph it, describe vertex and axis of symmetry. I'll give you a minute or 2 to get that done. Okay, Jet, can you give me the transformations?
Yeah. Right 2 and then down.
Excellent. Right 2, down 2. Okay, be specific about directions. Some people in their quizzes that I've graded so far, they maybe said like translate to, and then it's like where, what direction. So be really specific there. I'm going to go ahead and sketch that. Right 2, down 2. And then I'm going to create some new points. Up 1, left 1. Up 1, right 1. If you want an additional point, you could go up 4, left 2, up 4, right 2. Tegan, give me the vertex.
2, -2.
2, -2. That corresponds with right 2, down 2. So that's an easy one. And then Issy can give me the axis of symmetry. X equals 2. And I mentioned to a couple people as I was walking around, you have to write it as the equation of a line, so we need the x equals. If you just tell me the axis of symmetry is 2, you'll lose points there. Okay, 2 what? 2 left, 2 right, 2 up, 2 down, 2 a point, 2 a line. Don't know. Okay, x equals 2 is a vertical line. Okay, last one I want to do one with a stretch, just kind of model for you how you could draw your graph based on the stretch here. And so Luke had mentioned if you needed more points, you could always do a table of values. Know that that should be your backup plan. If you get to the test for chapter 1 and 2 and you totally blank on transformations, as a backup plan, pick some x's and y's and plug them in. And then hope you get the shape that you know you should get. Yes, I did. Mason, notice there's a reflection in the x-axis. I also said there's a stretch. Okay, so reflect in x-axis. A vertical stretch when it's on the outside there. It's not inside with x. Of 2. And what directions?
Left 3.
Left
Up
3, up 2. Okay, so I've got 4 transformations happening. Okay, plot me some little tick marks. You don't really have to do these on graph paper, but you can if you want. I'm also okay with decent sketches. So I'm going to go left 3 up 2 and get what is the vertex of my parabola. So now I know my vertex is at -3, 2. And then to apply the transformations of the reflect and the stretch, remember normally from your vertex you would go up 1, right 1, up 1, left 1. Because it's reflected, we would go down 1, right 1, down 1, left 1. And now it's being stretched, so now we're going to go down 2, right 1, down 2, left 1. So from where I'm at, I'm going to go down to left 1, down to right 1. Looks like I have x-intercepts at -2 and -4. Okay. Now, if you wanted to continue and do an extra set of points, side note here, then I would have to stretch the next set, which would normally be up 4, right 2, left 2. Then I would reflect it down 4, left 2, right 2, but then stretch it, so I'd really be going down 8. So just know that this is not like an absolute value where some people also wrote on their quizzes that there was a side slope. A quadratic is not going to have a side slope because it's not constant. So the slope changes from point to point.
So how does the stretch affect?
How does the stretch affect what? Well, okay, so I'm going to go down 8 and left 2, and then I'm going to go down 8 and right 2. So there's my 2 points. And then I'm going to draw this parabola. And we'll see. Can anybody see a difference? It's a little bit hard because I made my own scales. But anybody seeing anything on their paper or on my screen that looks like is happening to the parabola?
It's changing.
How is it changing? What does the stretch do vertically? It makes it skinnier. It should look like it's a little bit skinnier. Now I didn't use standard graph paper, so
Why is
it's
it
a little
called
bit
a
hard to
stretch?
tell. Why is it called a stretch?
If it's getting skinnier.
Well, you're stretching it vertically.
Oh.
And remember, like, if you put your face into, like, Photoshop, you take a picture of yourself and you pull down on your face. You don't pull the corner, you just pull down. What's going to happen to your face? You're going to get really long like a carnival mirror. So that's a vertical stretch. If you do a vertical shrink, what happens to your face? Flattens out, gets fatter, right? Okay, so that's what vertical stretches and shrinks would do to our graphs as well.
Why the second set of like points? Why would you go up to or like up 1
that is based on the parent graph. So remember we did parent graphs in chapter 1. Okay, so f of x equals x squared. But when we did f of x equals x squared, we used a table of values. And so when you plug in -2 and you square it, you get 4. When you plug in -1, you get 1, 0. So in the parent graph, that's the movement. The next one would be up 9, right and left 3. So you're doing the x squared part. Good question. I'm going to write my axis of symmetry right here. X equals -3. Any other questions? Are we okay on the stretch, making it skinnier? Now, if you think about horizontal stretches and shrinks, they do the opposite, right? If you horizontally stretch something, it looks fatter. If you horizontally shrink something, it looks skinnier. I always just imagine putting my picture in Photoshop. That makes it easy for me because I can imagine what happens to my face. Any other questions? Okay, nice job. Couple other things. Now, you're not going to see this on your homework today. It's going to be on your homework tomorrow, but I at least want to introduce it today so you can have a couple of days to digest this. Quadratics are going to have minimums and maximum values. When does your quadratic have a minimum? What must your quadratic look like? Okay, when the parabola opens up. And when does your parabola have a maximum?
When
When
it's going
it
down.
opens down. Okay, good. And does anybody remember how you can tell if your parabola is going to open up or down? Jacob.
There's something to do with the x is negative, doesn't it?
If something is negative, what would be negative in the vertex form? Luke? A. The thing way out in front, right? If immediately after your equal sign, you have a negative A, you're going to have a maximum. If you have a positive A, you're going to have a minimum. So just by looking at the equation, if I was given an equation like we were on the last slide, if I see that it has a positive A, before I even graph it, I know its vertex is a minimum. If I see it has a negative A before I graph it, its vertex has a maximum. All right, increasing and decreasing intervals. If I could get you in Algebra 2 to really understand that increasing and decreasing is in relation to the x, the left and the right of the graph, and not the y, the up and the down, that would be immensely helpful to you next year in pre-calc. Okay, so a lot of what we do are going to be the building blocks for your pre-calc, and next year will go a lot easier if you really know this information now. So increasing and decreasing intervals are in relation to x, which is left and right, not y. And for us, there's a really important x. It's the axis of symmetry. So remember, the axis of symmetry is some x equals line. Okay. This axis of symmetry is kind of like your borderline for when your graph changes from increasing to decreasing or vice versa, because remember that's where your vertex is, that's its turning point. So it turns around and changes directions. So every time you're looking for increasing and decreasing, imagine you're a person on the left side of your graph. As you walk along the graph to the right side, are you increasing or decreasing? This is decreasing. And then when you get to the vertex, you turn around and you start increasing. So when you write an increasing and a decreasing interval, here it's going to be for x's less than h to the left of your axis of symmetry, and your increasing is going to be for x's greater than h to the the right of your axis of symmetry. Remember, H is what the axis of symmetry is. Could be any number. And then if you're doing the upside down parabola, those things are flipped. You're increasing for x is less than h, and you're decreasing for x is greater than h. In no way does it matter what the min or maximum y value is. So the k should never be part of increasing or decreasing intervals. They should be along the x-axis, horizontal. On the left side you're doing this, on the right side you're doing this, in the middle you're doing that. We could change directions a lot of times in the graph. Alright, so let's see that put to work in an example. We've got f of x equals negative, the quantity x plus 1 squared minus 3. And I'm going to do these three things without graphing. Yeah, how? We're just going to think about it. We're going to make sense of it. So 3 things that we want to do. We want to find the minimum or the maximum value. If it's a quadratic, it will have one or the other, not both. I want to describe the domain and the range. And I want to determine where the graph is increasing or decreasing without a graph, if possible. Okay, so I'm going to give you a couple minutes with your small groups. You may make the arguments to your group members on the answers to any of these 3 questions. If no one is convinced, you may draw a graph or describe to them the characteristics of the graph. Okay, so take a couple minutes, go. Should be lots of talking.
Okay, so the domain is the range. The range is already.
So it's nice to get all your range.
That's an easy one, yes. Good, you got it.
It's the outside of the
Yeah.
class.
Less than or equal to -3.
So it's maximum.
Max.
It is
Maximum
maximum.
means that vertex is the highest point in the process to get. Because it's going out, and so the vertex is going to be -1, -3.
No, it's going to it's going right one down.
Maybe -1. So you got to do this. Right? Because you got to do the opposite.
Yeah, it's not. Negative. Oh, it's going less. It's going less than 1.
We're not doing change yet. Yeah, we're not doing change. But she told me to write H looks like the opposite when it goes to the parentheses. So H is 1, and so you gotta do the opposite of the thing. And then the function is increasing.
What is H greater than I?
It's decreasing after negative 1 and 3. Maximum is negative 1. Rate is already numbered. Range is less than or equal to What was that?
It is ringing.
Is it? I don't think it is.
Okay, Colin, was your group able to decide if this had a max or a min? You said maximum. Do you remember why your group said maximum? Okay, because it's opening down. Because A is negative. Okay. And then what was the max value?
-3.
Colin? -1? So you just said -1? It Ashlyn, what did you guys say?
-3.
Just 3? Just -3?
No. Yeah.
So I guess this is a kind of like a trick question here. Okay.
That's what we said.
Where is the maximum point happening? At the vertex, right?
Yeah.
Okay, so if it's asking find the minimum or maximum value, do they mean the ordered pair? Okay, so you could write -1, -3, or the maximum value of the function would be like your max y value. So in the vertex, the max y value is -3. I'm gonna say, let's practice this one, like labeling the vertex for the maximum, because there is something that -1 is working towards at the maximum. It's when you reach your maximum. Later on, when we use quadratics to model things, we may want to know like how high a ball is kicked, and then how far away from us it is when it reaches its highest point. So we'll want both parts of the maximum. Okay, they're both sort of pieces of the puzzle. Okay, so let's write it as an ordered pair. Okay, domain. Ashlyn, what did you guys say? X equals all real numbers. That should be an easy one. Range. Taylor, you want to give us yours? And I'm going to change that to y. Okay, because we're talking about range, which is y is up and down. So y is less than or equal to -3. Why did you choose less than or equal to? -3 was just described as our max value, so we shouldn't have anything above -3. Everything is below less than or equal to. And it does include -3 because you can actually be -3 at the vertex. Okay, increasing and decreasing. Josh, you want to give us your increasing interval? X is less than -1. So what they're saying is they chose less than because it's increasing on which side of the parabola? The left side. Okay. So here we're increasing. So that's the left side of the axis of symmetry. Okay. So x is less than -1. Where would your decreasing be then?
On the other side.
X is greater than -1.
Did you put or equal to, or is the vertex count?
So that's an argument that you could have, like in a calculus class, whether you would include it. But I would say don't include the vertex in either increasing or decreasing, because you wouldn't know which one it's doing, and it's actually just turning around. So since it's where it changes direction, then I would not include it in increasing or decreasing. Those are in calculus points you call critical points. Those can be points where it changes direction, it changes inflection, and it's hard for us to say what's really happening there. All right, last thing. We've done a lot of work with, given an equation, can you graph it? Given an equation, can you tell me max, min, and domain? Given an equation, tell me all this stuff you know. Now it's given some information, some description, can you write the equation? So this kind of takes us back to the beginning, the early parts of chapter 1, when we were being asked to do transformations to different functions. Let the graph of G be a vertical stretch by a factor of 2. Think about where that goes. And a reflection in the x-axis. Think about what that looks like. Followed by a translation 3 units down of the graph of f of x equals x squared. Write a rule for G and identify its vertex.
Write an equation.
Yeah, write an equation. Okay, so how do you do a vertical stretch of 2?
No, just 2.
If you're just doing a vertical stretch of 2, it would just be 2 plus 2 times 2 minus
2.
2 times. Okay. 2x squared. How do you reflect it in the x-axis? Make it negative. And then followed by a translation 3 units down. How do you go 3 down? Minus 6. Remember, we had talked about this whole issue in chapter 1, what if order matters. Sometimes it does, sometimes it doesn't. In the case that it does, just do them one thing at a time. Okay. Now, you might be able to do, like we were saying, -2 in the very beginning. You might be able to double up some, and that's fine. But just be aware on the test for chapter 1 and 2, order could matter, so be very thoughtful about that.
If so, like, so it says down 3, and if they added, like, to the right 2, like, would you put it in parentheses, or would
Yeah.
you just simplify it? You put it in
Yeah,
parentheses,
the parentheses. If it said right 2, you should do a parentheses x minus
and
2.
then the square root would just go inside.
The square will go outside. A square root is that radical thing. Okay. Try one on your own. Let the graph of G be a vertical shrink by a factor of 1/2, followed by a translation 2 units up. Ooh, these are easy.
Did you do that?
Not right now. Just wait until notes are over. Thanks. We're almost done. Vertical shrink. Multiply by 1/2 on the outside. 2 up. Add 2. There's our equation. I might add some extra things for 7th hours. They have a little more challenge. Okay. All right, here's your homework assignment. It's on your gold sheet, right? Notice that you're only required to do the bolded problem, so that would be what? 6,
18.
8, 11, 14, yeah, 18 problems. That's reasonable. Okay, when some of them are like easy. Yeah. Okay. But when you're doing the graphing, the most important thing for tonight is transformations in the graph. But I would add in vertex and axis of symmetry. So that'll help you for tomorrow, okay? All right, we've got about 7 minutes. So if you don't have a textbook, have someone from your pod go grab one. They're over by Jet and they're covered. Okay, so ours are the covered textbooks over there. Send someone to grab a textbook and get started on those first few problems, all right?